Okay, in this video we're just going to talk about the three elements that make up any basic electrical circuit. And I promise we will eventually get into the more complex aspects of electronics as they relate to the field of communications. But before we get there, we need to just talk about what are the most basic elements of any type of electrical circuit. So let's get started. Before we talk about the three basic elements of any electrical circuit, let's just do a quick review of what we covered in the last video. In the last video, we talked about the atom and the fact that every atom contains positively charged particles called protons and negatively charged particles called electrons. Protons are found in the center or nucleus of an atom, and the electrons orbit around the nucleus in a series of layers or shells. It is the movement of electrons that creates a flow of usable energy that we call electricity. We also talked about the fact that all atoms contain a maximum number of 8 electrons in the outermost shell, in other words, the one that's farthest from the nucleus or center of the atom. We discussed the fact that materials with only 1 or 2 electrons in this outermost shell are called conductors because they give up these electrons easily, which results in the flow of electricity. Silver, copper, and gold are examples of good conductors. We further talked about materials that have more than 4 electrons in this outermost shell, and because these types of materials are more stable and do not give up electrons easily, these materials are called insulators. Rubber, wood, and glass are an example of good insulators because these materials do not conduct electricity very easily. Finally, we talked about atoms that have exactly 4 elements in this outermost shell, and these materials are called semiconductors, and they can conduct electricity under the right circumstances, but they're not good conductors, nor are they good insulators. These are called, as I said, semiconductors, and they are used in transistors and diodes. So, having reviewed that, let's go ahead and talk about the 3 basic elements of any type of electrical circuit. The volt. When we talk about voltage, a lot of people think that voltage has to do with the movement of electricity, and that's actually not completely correct. Voltage is referred to as electromotive force, and what it is it represents a difference of potential between 2 points. If you'll recall from the first video, we talked about how electrons exert a negative force, or they exhibit a negative charge, and that protons exhibit a positive charge, and we also talked about how unlike charges attract. So let's imagine for just a moment that we have 2 poles. These poles could be the terminals of a battery, or they could be the 2 ends of a wire. And let's say that on one of the poles we have an excess of electrons, which creates an overall negative charge, and on the other pole we have an excess of protons, or in other words, an absence of electrons, creating a positive charge. If we were to measure the difference in potential between these 2 points, in other words, the difference in the number of electrons, that is the voltage, or the force, which causes electricity to flow. It's not the movement itself, but rather it's the pressure or the force that causes electricity to flow. And you can kind of see from my illustration here, one pole has an excess of electrons and the other has an absence of electrons, and this creates this force that when you provide a path for electricity to flow, this force or difference of a potential will cause electricity to flow. And remember also that essentially when we're talking about the flow of electricity, we're just talking about the force that's unleashed by the movement of electrons through a circuit. So one of the 3 basic elements of any electrical circuit is voltage or pressure. In technical terms, the volt is the amount of force needed to cause 1 coulomb to produce 1 joule of work. A coulomb represents 6.25 times 10 to the 18th power number of electrons. That is a massive number of electrons, but that is the basic unit of measure. So the coulomb is a basic unit of measure that's used in the field of electronics. As I stated before, the volt is not the movement of electrons itself. It's this difference of potential that causes, it's a force that causes the movement of electrons. And we talked about in the first video how analogies were helpful in understanding some of these principles. If you think about like a water tank or any type of a water system, you have your pipes, you have a place where water is stored, and you've got valves. Within any type of a water system, you're going to have pressure that's exerted just by the water itself, the forces of gravity and the water and the valves. Well, the voltage in an electrical circuit is similar to the pressure that you'll find in a water system, and this pressure will cause movement once you open a valve in the water system, which allows water to flow. The volt is very similar in that it represents a sort of electrical pressure. Another element that you'll find in pretty much every electrical circuit or electronic circuit is current. Now, when we talk about current, as its name implies, we actually are talking about the flow of electrons or electricity. And current is measured in amps. The amp is the measure of current flow. It's defined as 1 coulomb per second. In other words, the amp is the movement of 1 coulomb, which represents this massive number of electrons per second past a given point in an electrical circuit. And this will actually make more sense when we put all of these elements together in just a second. Okay, let's go to the next one here. So we talked about that there are 3 basic elements in any electrical circuit. We have the electrical pressure, which forces the electrons to flow or move once there is a complete path for current flow. We talked about the current flow or the movement of electrons itself, which is measured in amps. And there's a final element that's present in pretty much every electrical circuit, and that's resistance. And what resistance is it is the hindrance of current flow through a circuit, and resistance will be measured in ohms. All of these properties are related to each other. So we can use, for example, amps and ohms to sort of define what a volt is. And so it can be said that a volt can be defined in terms of current and resistance. 1 volt is the amount of force or electrical pressure that's required to force 1 amp of current to flow through 1 ohm of resistance. And remember, 1 amp represents the movement of 1 coulomb, this huge amount of electrons per second past a given point. So when we talk about a volt, we're talking about the amount of pressure or force that's required to push this massive amount of electrons represented by 1 amp through 1 ohm of resistance. Now you may have noticed already that all of these properties are interrelated. So for example, if you increase the voltage, you're going to also increase the current because these two are directly proportional. So if you increase the voltage or the electrical pressure, then that means the current will also increase. Related to that, the current is inversely proportional to resistance. So what that means is that if there's an increase in resistance, this will actually lead to a proportional decrease in the amount of current flow. And since all of these properties of an electrical circuit are proportional, the relationship can be expressed in a formula. And that formula that we have to analyze these various properties is called Ohm's law. So let's talk about that. Ohm's law. The relationship between voltage, current, and resistance can be expressed in the following formula. E equals I times R. And the formula where E equals the electrical pressure or force, which is measured in volts, as we talked about, where I equals current flow, which is measured in amps, and where resistance, or where R equals resistance to current flow measured in ohms. This formula can also be rearranged to solve for different values. So, for example, if I wanted to solve for current, then it would be I equals E over R, or if I wanted to solve for resistance, it would be R equals E over I. So the basic idea is that if any two values in the circuit are known, you can use Ohm's law to solve for the missing value. So let's put this to work and see how these different properties can be used and analyzed in a simple circuit. Okay, let's say that I have a circuit that consists, it's a very simple circuit, it's a series circuit because it just has one path for current flow. It's only got one load. So let's say we have a circuit which consists of a battery as our power source and a light. And we know that the battery supplies 12 volts, and we also know that there's a current flow of 2 amps. So how much resistance does the load offer to the flow of current? Pretty much every load that you come across in an electrical circuit will offer some resistance to current flow. In the case of a light bulb, a lot of the resistance is in the form of heat, which is dissipated in the circuit. Of course, the heat in this circuit also is what produces the light, and so it's actually producing useful work. But nonetheless, whenever you attach or connect a load to an electrical circuit, there will be some resistance on the part of the load itself. So to figure out how much resistance this load is offering to the flow of current, we can just use the Ohm's law formula. Let's see how that works. So we know that the voltage is, we know that we have 12 volts supplied by the battery. We also know that 2 amps is flowing through the circuit. So we can use our E equals I times R, and we can plug in these values to solve for the unknown value, which is, in this case, the resistance. So we would put in 12 volts for E, and we would put in 2 amps for I, and then what we have to do is rearrange the formula so that R is isolated on one side and the other values are on the other side. So what I'm going to do is divide both sides of my equation by the 2 amps, and that gets the R by itself on one side of the equation. And when I do that, I wind up with 12 over 2, which if you just do the simple division equals 6. So we know that we have 6 ohms of resistance that are flowing, in this circuit that are presented by the load. By the way, in the field of electronics, the omega symbol is used to represent ohms, and as I've done here. Okay, so we've covered the basic aspects of an electrical circuit. We talked about the 3 elements. One final aspect that I wanted to talk about. In order for current to flow in a circuit, you have to have a complete path for the current to flow. If there's any break in the circuit, then there will be no current flow. And this assumes that we're talking about a series circuit for the moment. For the basic idea, since it's the movement of electrons that actually causes the electricity to flow, when we're talking about current flow, it's going to flow from the negative side or the negative terminal. In the case of our circuit that we have here, it's going to flow from the negative terminal of the battery to the positive terminal. So if at any point that circuit is broken, let's say that the wire breaks or something like that, or let's say that you put a switch in there someplace and you open up the switch. When that switch is open, no current will flow. You will have a voltage or an electrical pressure, but unless there's a path for current flow, you will have no current flow. So one of the basic rules for electrical circuits is that there must be a complete path for current to flow. In conclusion, we talked about the 3 basic elements of all electrical circuits. There is an electrical force or pressure, which is measured in volts and which causes the movement of electrons, but it's not the movement itself. The movement is called current, and it's measured in amps. And then there's always going to be a little bit of resistance to current flow, and this resistance is measured in ohms. And then we talked about how all these properties are related and how that this relationship can be expressed in the formula that's referred to as Ohm's law. Remember that voltage and current are directly proportional. So if you increase the voltage, then the current's going to go up. Remember also that current and resistance are inversely proportional. So if you increase the resistance, it's going to cause the current to drop proportionally. Likewise, if you lower the resistance, it's going to cause a proportional increase in the flow of current. Now in the next video, we'll talk about the most basic electrical circuit there is, which is the series circuit. And we'll also talk about Christmas lights. I don't know if you've had the problem or not, but if you've ever bought Christmas lights before, if you've bought a string of lights that are wired in series, what happens is when one of the bulbs burns out, because the string is wired in series, it causes all of the bulbs to go out. And it can be a real pain to figure out which bulb is burned out. And we'll talk about how you can avoid this problem by buying a string of lights that's wired in parallel, because you don't run into this problem with parallel circuits because there are multiple paths for current flow. So that's what we're going to start talking about in the next part of this series on electricity. I hope you learned something, and thanks for listening.